Okay, next up, let's talk about a unit circle. And the unit circle is pretty amazing. It's something we use a ton when we're dealing with trigonometry, sine, cosines, and tangents. And since I call this a unit circle, the reason it's called unit is because its radius is 1. So when I say its radius is 1, the distance from the middle to this point right here on this circle is 1. The distance from the middle to this point up here, that's the point 0, 1. From here over to, or the origin over to here, would be 1. So that point would actually be negative 1 comma 0. So keep that in mind. So this is going to be important anytime we're dealing with the unit circle. Remember, the radius is 1, and there's some other distances that we need to know. Because on this unit circle, when we're looking for sines and cosines, we need to know some distances. The distance from here up to here, you can see over here on my little chart, that distance is going to be 1/2. The distance from my x-axis up to 45 degrees, that distance is root 2 over 2. Up to 60 degrees, that distance is root 3 over 2. Then up to 90 degrees, we already know that that distance is 1. Those distances are symmetrical. The distance from my y-axis over to 60 degrees, notice, is also 1/2, just like it was up to 30. Over to 45 would be root 2 over 2, and so on and so forth. Those distances are the same. So what I need you to know now, what I need you to understand, if I ask you ever for a sine of an angle, the sine of an angle is simply how far is it from my x-axis up to that 30-degree point, the point where that 30 degrees crosses the unit circle. The distance, the sine of 60 is the distance from here up to here, which would be simply root 3 over 2. And also, we need to understand that those distances flip-flop. If I knew the distance up to 60 degrees is root 3 over 2, then obviously 120 degrees is the same distance up because of the symmetry. And you've also got two angles down here, this distance down to 240 or this distance down to 300 would also be root 3 over 2. So a sine value is the y value. It's how far up or down an angle is. A cosine value is an x value. It's simply how far over is an angle. So now let's work some problems. If I were to ask you what's the sine of 45 degrees, again, if you learn to count 0, 1/2, root 2 over 2, root 3 over 2, and 1, we're counting up to angles. 45 degrees is right here. So my distances are 0, 1/2, root 2 over 2. So my y distance there would be root 2 over 2. The sine of 45 would be root 2 over 2. The cosine of that same angle, if I were to ask you for the cosine of it, then we would count over. My distance is 0, my distance is 1/2, my distance is root 2 over 2. Since it's in the middle, it makes sense why its sine and cosine values are the same thing. Now, if I were to ask you, let's do some of these problems over here now. If I were to ask you for a different quadrant, let's do maybe the cosine of 7 pi over 6. Notice it's also in radian measures. I got to plug in 180 for pi. Divide 180 by 6 gives me 30. Multiply it by 7, that's the cosine of 210 degrees. The way I teach this is we're going to find what's called a reference angle. The reference angle is the angle that 210, which if you don't remember, here's 180. 210 would be just past it. We need to find out how far past it. How far is my actual angle that I'm finding past 180, or how far is it from 360? We're going to use that angle then and the distance of the reference angle in order to find this problem. So first off, the cosine of 210. Again, I'm looking for an x value here. Something else that let's take care of before we begin this problem, though. Since we're traveling to the left, okay, we're looking for the cosine, the x value of this point right here. Since we're going to the left, we know that our cosine value is going to be negative. Then you ask yourself, what is my reference angle? Mark out 210, and since 210 is 30 degrees away from 180, we're going to simply do the cosine of 30 versus the cosine of 210. And we know the cosine of 30, again, cosine is this distance right here. So therefore, the cosine of 30 would be 0, 1/2, root 2 over 2, root 3 over 2, and we can see that up here at our distances. So therefore, our answer for cosine of 5 pi over 6 or 7 pi over 6 would be negative root 3 over 2. Now let's try another one. The sine value, we're going to plug in 180, divided by 3, multiply it by 10, and we're actually doing the sine of 600. Now, we've got a sine value here that's over actually 360. So what I'm going to do first off, I know that if I were to take away a rotation, it's the same angle. It ends up in the same place. So that's perfectly legal. You can either add rotations or take away rotations to the angle you're finding. Now, the sine of 240. 240 is in my third quadrant. This is 180. Since we are looking for the y value and my point goes down, my y value is going to be negative. Then once I find out if it's positive or negative, I can mark this out and I can find what we call its reference angle. How far is it from 180? And that'd be 60 degrees. So really what we're looking for is the distance, the y distance at 60 degrees, which is the distance from here up to here, which is root 3 over 2. And that's going to be our final answer, negative root 3 over 2. Now, lastly, let's deal now with the tangent, how we can find the tangent. There's two different ways we can do this. The first way to find the tan of, we'll do 30 first. The tan of 30. Tangent is always y over x. It's always sine over cosine. So one way of working it is you could actually find the sine of 30 over the cosine of 30 to do the tan of 30. Sine of 30, this is a y value over an x value. Sine of 30 is a half. Cosine of 30 is root 3 over 2. When you flip and multiply to divide, the 2's will actually cancel each other out and give you 1 over root 3. Once you rationalize by multiplying top and bottom by root 3, you get root 3 over 3. Now, here's another way of working it, though. Since tangent is y over x, tangent is actually the same thing as slope. So therefore, if you can remember these slope values, you can work tangent the same way you do sine and cosine. So here's the 4 different slope values you need to remember, and some of them you already know. The slope of this line right here is 0. The slope of a 30-degree angle is root 3 over 3. The slope of 45 degrees, rise and run are the same, it's 1. Slope of 60 is root 3, and the slope of 90, a vertical line has an undefined slope. So therefore, if I were to ask you, we're going to work it the same way. If I were to say, what is the tangent of 300 degrees? Step number 1, you would ask yourself, you can either do, is my slope positive or negative? Is my sine and cosine positive or negative? Or here's you another trick. In order to find out if your answer is going to be positive or negative, this is a neat trick that you can use. Remember this saying, all students take calculus. We're going to go into a counterclockwise direction. All students take calculus. In this first quadrant up here, everything is going to be positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. In the fourth quadrant where we're at, only cosine is positive. So therefore, at 330 degrees, cosine is the only positive, which means sine and tangent would both be negative. So therefore, my answer here is going to be negative. Again, next step, you're going to mark out the 300 degrees. You're going to find out how far is that 300-degree angle from 360, and that's 60 degrees away. Then we simply find the tan of 60. And if you remember those slopes, they were 0, root 3 over 3, 1, and root 3. So the tan of 60 is root 3, so the tan of 300 would be negative root 3.